Question show time. Your questions, my answers. As always, wherever you are on my channel, if a question pops into your brain, type it in. I see them all. I see everything. And I will gather them up and I will answer them here. All right, let's get into it. Dan. Hi Fraser, love your work. Keep it up. I have a question which is seriously bugging me. When we look at stars or galaxies in the far distance from our Earth, people say that we are essentially looking in the past, which is fine, and I get that, as I know the light from these objects took some time to travel to Earth. But the real question is, does this mean those objects could be dead already? Have you ever heard that saying on the internet where when you look up into the night sky, all of the stars that you see are really dead, like your dreams? So it's not true. So yeah, you're absolutely right. When we look anywhere into space, we are looking backwards in time because light moves at the speed of light, which is very fast for us here. But when you look at, say, Alpha Centauri, it's 4 light years away. When you consider places like the heart of the Milky Way, you're looking at 26,000 light years away, and that's 26,000 years ago. So Andromeda, 1.5 million light years away, 1.5 million years ago, the very edge of the observable universe, 13.8 billion years ago. So absolutely, you're looking backwards in time. But the reality is when you think about like what you can see in the night sky, when you look up in the night sky, what you're seeing are bright stars that are within a few hundred light years of the Earth. So when, you know, I forget the exact number, you can see something like 8,000 or 9,000 stars with dark adjusted eyes, and they're all within about that sphere. Some are a little brighter, so they're a little further away, some are dimmer, so they're closer. But what's the chance that some star that is, say, 200 light years away has died? The chances are very remote, right? Many of these stars, they're going to live for billions of years. The chances that anything different is going to happen to any of those stars in the night sky is super remote. It's only on the really extreme situations, like when you think about, say, Betelgeuse, right? At some point, Betelgeuse, which is just a few hundred light years away, it's going to explode as a supernova, and it will have exploded several hundred years before we realize. And so in a couple of edge cases, it's entirely true. Or when you think about supernova 1987A, which was in the Large Magellanic Cloud, which is hundreds of thousands of light years away, it actually happened hundreds of thousands of years ago. I know your brain will kind of go crazy thinking about that. But roughly, for the nearby universe, what you see today is what's still there now. For the mid-ranges, Andromeda is still there. When you look out to the extremes, like the billions of light years away, yeah, they can be completely different structures. The stars that we see today there are probably long dead. Brand new stars have taken their place. What we see today in that galaxy is not what it was when the light left that galaxy. And that's just sort of the reality. It's the advantage of astronomy, and it's also the downside. Gavin Minton. Can dark matter, whatever it is, fall into black holes? If so, would black holes be composed primarily of dark matter since there's more of it than regular matter in the universe? All right, well, I gotta preface this, of course, by saying we have no idea what dark matter is. But all evidence seems to be pointing towards this idea that dark matter is a particle. And so if dark matter is a particle, then it would absolutely fall into a black hole. But the thing is that the amount of dark matter that's going to fall into black holes is probably going to be a little lower than regular matter, and I'll sort of explain. So when you've got a black hole, and say a star gets too close to the black hole and the tidal forces tear it apart, then the star, all this material will start to fall into the black hole, and it's too much for the black hole to feed on, and so the material piles up into this accretion disk around the black hole and sort of waits its turn and gets ground up and then finally makes its way into the black hole. And sort of this gas and dust is sort of bashing into each other and getting piled up. The problem is that it seems like dark matter, whatever particle dark matter is, it has essentially no cross-section, which means that it doesn't sort of bonk into itself or to regular matter. And there's been these great observations made, like the Bullet Cluster, where these huge clouds of dark matter pass right through each other and they don't collide and form any larger concentration of dark matter. Well, gas and dust does. They collide, they sort of bunch up, and they create this area of larger density. And so the dark matter particles, they're not going to bounce into each other and get ricocheted in and sort of build up into this accretion disk around the black hole. If it's a straight shot, then the dark matter is going to go into the black hole. But if it's a real near miss, then it's just not going to bunch up in the way that regular matter does. So if dark matter it's on a direct line with the black hole, then it'll go in. If it crosses the event horizon, it's going in. But apart from that, it's probably not going to make it into the black hole. Arne Jolo. Okay, Fraser, how about this? Don't send up any people to repair or replace the Kepler reaction wheels. Send up a small module that can clamp onto Kepler and act as an external reaction wheels to get it to maneuver accurately again. Sounds like something that could be light and cheap to launch. Maybe use a Rocket Lab Electron to get there. It would be huge to get Kepler working again. Tell me why this idea is full of holes. That idea is not full of holes, and there are a couple of companies. I think Orbital ATK is working on a satellite rescue spacecraft, and it's going to do exactly what you're talking about. So you take a satellite that is working perfectly. All of its communications are there, its power systems are there, it's for all intents and purposes, it's still got a lot of life left, but the problem is it's out, say its reaction wheels have died or it's out of propellant, and so it can't reorient itself anymore. And so the idea is you send up the spacecraft and it has additional propellant or reaction wheels, clamps on however it can to the satellite, and then gives it a second life. And there are a couple of these spacecraft in the works, and over the next couple of years, you're going to see some satellites get this sort of second life thanks to these repair spacecraft. But it's always an issue of cost, right? So let's say that you've got the Kepler spacecraft and it cost about $400 million to launch and to build and launch. And TESS is more like $200 million to build and launch. So say you're looking at a SpaceX rocket, it's going to cost you $60 million. You've got you're going to have to build this additional launch vehicle. You're going to have to build the clamp vehicle that's going to be able to attach to it. Now, Kepler is drifting pretty far away from the Earth, so you actually have to go on a much more complicated trajectory than just a regular orbital spacecraft. So you're looking at a couple of $100 million to send your rescue vehicle to rescue Kepler. Do you want to do that, or do you want to maybe invest about that amount of money or maybe a little more money and get a brand new spacecraft with brand new everything, brand new cameras, brand new propellant, brand new reaction wheels, newer electronics, and put it into maybe a different orbit and maybe answer some different science questions than the ones that Kepler was answering? So this is just always this trade-off, and we're now entering an age where rescuing spacecraft like this is becoming economically feasible. It's possible, but always there's going to be this give and take. There's going to be this sort of, they're going to have to justify the cost and figure out which is the right way to go. Alfredo Gonzalez. Could all the galaxies be small points of light in some bigger galaxy-like structure along other similar structures? Where do you think most of the observable universe is in? So when we look at the universe at the largest scales, right? Let's just imagine we've got the Milky Way, and you sort of zoom out from the Milky Way and you see the local group. You see Andromeda and M33, M34. You see all these sort of local galaxies. You see the Magellan clouds. You see all of the clouds in the local group, and it's sort of like this clump of galaxies. And then if you zoom out further than that, you get the sort of the Virgo supercluster, and it's sort of like it's that local group, but now it's a larger structure, and you're seeing now clusters of galaxies arranged, and it almost looks like it's a fractal thing as you get to a larger scale. And if you go further out than that, you see these enormous structures, these huge walls, and it looks like you've probably seen the picture of like neurons. It looks like kind of like neurons, and it's at the largest scale. You're seeing the large scale structure of the universe with these voids in between and bubbles and things like that. And so you would think that if you go one more scale out, those are going to sort of shrink down. You're going to see even bigger walls and voids and structures like that, but you actually don't. So there is no, if you see the universe at the largest scale, those big structures are there, but you won't see a repeat of that at any larger scale. So the universe isn't fractal, and it's interesting to know that that's the case. That that repeating structure that we see ends at that large scale, what we call the large scale structure of the universe, and doesn't go beyond that. So if you could kind of get out of the universe, you would see, if the universe was really far away from you and you could sort of see it as a sphere, it would look like a ball without any features. And as you got closer, it would start to look like a sponge with holes in it. As you got even closer, it would look even more like a sponge. And as you got even closer, then you would really start to see these larger holes and gaps and walls and things like that, which is pretty fascinating to think about it. OTR resident, how far off do you think we are from 3D printing an entire space station with this lower building cost? We're a long way off from 3D printing things like space stations. Now, on the ground, it's kind of amazing how far the 3D printing technology has gotten. At SpaceX, they 3D print a lot of parts, like titanium parts for some of their rocket motors. There's a company that is working on 3D printing as much of the rocket motor as they can and reducing the number of different parts in their motor by a factor of 10 or more. In space, they're testing 3D printers on the International Space Station. One of the astronauts lost a wrench, and so he was able to print himself a new copy of that wrench on a 3D printer in space. And so there's a lot of development happening here on Earth. I've seen someone shared a video at me of someone who took like sand in the desert and was able to 3D print like a bowl with lasers in the, fully out of solar power. Now, one application that we're starting to see, people are testing is, what about 3D printing structures on the moon or on Mars? You could build some kind of gadget that would use the local regolith and build an igloo on the moon or on Mars, something like that, out of rock. And so you're going to see that. I think that would definitely be, when we have achieved sort of mastery of exploring the solar system and we're able to build things in space and construct them, 3D print them, then I think we will be well on our way to being a solar system spanning civilization. But we are very, very far away from that right now. A plastic wrench, that's where we are right now. Luis Fernando, are we 100% sure that Alpha Centauri is the closest star from us? Is it possible that we have a closer planetary system? It depends what you mean by planetary system. So, the closest star to us is Proxima Centauri, and it is a red dwarf star. It's like one of the smallest possible stars that can still have fusion in their core, and it is part of the Alpha Centauri system. So there's two sun-like stars that are with it. And if you're in the southern hemisphere and you know where Alpha Centauri is, it looks like one very bright star in the sky, one of the brightest stars that you can see. So the question is, are there planetary systems, star systems that are closer than that to us? The chances are no. We would be able to see it, right? So when you think about things like brown dwarfs, right, they're a lot dimmer, a lot cooler, a lot harder to find, and there can be closer ones. Fairly close brown dwarfs have been found, but they're sort of very difficult to find. But they have been discovered relatively close to us. I think we can feel pretty confident that we know of where the closest stars are to us in the local area of the galaxy. Kim Wow Boom. Fraser, we're becoming the cause of our own extinction. Why aren't we doing much? Or will some survive because we are adapting to changes? What should evolution do? So you're wondering, why aren't human beings taking care of our environment and minimizing the amount of species that are going extinct and pollute? That's what we do, right? That's human beings. We like to have the good life. We like to have our cars, and we like to drive around, and we like to have electricity, and we like to fly in our airplanes, and we like to go on vacations. And the consequence is animals and plants die, and we burn up forests, and we pollute the air, and that's just sort of what human beings do. So, and it really kind of seems like now, amazingly, the rise of renewable energy, things like the fact that solar power is now the cheapest way of generating electricity that there is. Various countries are taking up these kinds of alternative or clean energy sources faster than ever before, is going to have a natural response to sort of improve the environment over the long term. And this is why I really like Jeff Bezos, the founder of Blue Origin, the richest man on earth, the founder of Amazon. His philosophy is that we should use space as a place to do all of our polluting. Let's take all of this heavy industry, all of the power generation and let's just get that off into space and then send down the finished products when all the polluting is done and it's all been done out in space. But I think, you know, unfortunately, we are human beings. We think to the short term, we always have, and we probably always will. And hopefully every now and then we get our act together and we figure out that we should like get rid of the chlorofluorocarbons to reduce our impact on the ozone layer, or reduce sulfur dioxide emissions to reduce acid rain, or pull the lead out of gasoline because people are getting sick. So I don't know. I think it's more of a psychology question. Aidan Graysley. Hey Fraser, do you think that we should send more landers or orbiters to Venus and Mercury? There were never many successful Mercury or Venus missions, although the later Veneer landers were all right. Do we still have anything to learn from them? I think it's safe to say that we always have everything to learn from everything. That we could send 1,000 landers to Venus and Mercury and still not have learned all of the lessons that we would like to learn from those planets. Now, there was the Mercury Messenger spacecraft, which recently died, and there's the Bepi-Colombo, which the European Space Agency is sending to Mercury. There was the European Space Agency's Venus orbiter, and now, no, that's it. There's nothing else in the works for Venus, but there have been some missions sort of potentially getting planned. Europe is thinking of sending another Venus mission. I would love for us to go back and to like use some of the newer technology. And one of the things that's most fascinating to me is that engineers are developing a way that they can actually run electronics in the super hot, high pressure conditions of Venus for months at a time. So we've sort of got a time when we could have a viable mission to Venus that could actually land on the surface and rove around. I think it would be great. So we should always send more missions to everywhere, and especially Mercury and Venus. Elementus. Since Mars is in the habitable zone and it became uninhabitable due to its small mass causing it to lose its magnetosphere, could it be habitable if it has similar mass to Earth? If Mars had more mass than it does today, if it had the same mass as Earth or Venus, it would be a much better world. Sorry, Mars, you just didn't get enough mass. And for a bunch of reasons. So the first one is, of course, as you mentioned, the magnetosphere. Mars is smaller than the Earth. It cooled off a lot more quickly than the Earth did. And it looks like it's probably solidified all the way through, although NASA's Mars InSight lander is on its way there now, and when it lands it's going to be quietly listening for any kind of volcanic activity on the surface of Mars. So we'll find out if it is as active or not as what I said. And then the other part is that it doesn't have enough gravity to be able to hold onto its atmosphere. And so the solar wind from the sun came in, blew through, and blew away its atmosphere a long time ago. And even if we were able to provide it with an atmosphere today, the sun's solar wind would continue to get rid of it. So if Mars was the mass of Venus Earth, it would have probably a magnetosphere, although Venus doesn't have a magnetosphere, but it have a higher chance of it, and it would be able to hold onto its atmosphere a lot better than what it can right now. And there's some really interesting research that's out fairly new that really it's the giant planets, that Mars was so far out that the giant planets, Jupiter, Saturn, etc., interacted with it and starved it of mass. And so if it wasn't for Jupiter and Saturn, Mars would probably be a lot bigger, but they caused all this instability as the solar system was forming and Mars lost a lot of its mass. So Mars sucks. Ben Appleby. Thanks for another great video. Could a galaxy collapse in on itself? If so, what would happen? Would you get an insane-sized black hole or a star? Well, that's sort of the same kind of question as saying, could the solar system collapse in on itself, right? The solar system is essentially perfectly stable because the sun is at the middle, the planets formed out of this rotating disk of material that was around the sun, and then they cleared out their orbits and they keep going. And they are essentially moving on this trajectory that is the leftover momentum from their formation. If they were going any faster, they would raise their orbit. If they were going any slower, they would lower their orbit, right? They are going the perfect speed to maintain their orbit forever. And that's what's happening with all of the stars in the Milky Way. They're orbiting around this collective center of the galaxy, and they're going to do that for as long as the galaxy exists. There's going to be no force. Now, if you could somehow crash the Milky Way into another galaxy and messed up their gravity so that you would sort of reduce all of that momentum that all of those stars are having, then they would go inward to the middle of the galaxy. But there's no reason to say it. There's no reason why a galaxy would collapse in on itself, just like there's no reason why the solar system would collapse in on itself. Fellow traveler, do you consider James Webb a disappointment, seeing how the telescope has been delayed so many times that the number of delays is in the double-digit numbers, and that we can't take the 2020 launch date for granted, seeing how we've been in a situation so many times? Am I disappointed? Well, yeah. I mean, like, disappointed in that James Webb is the most powerful space telescope that's ever been conceived and built, and it has been in development for a very long time, and we're in the final stages of it now, in theory, but new problems keep happening. They just did a shake test of James Webb, and they found a bunch of screws and washers, like, when you put together IKEA and you got a bunch of leftover parts. So that needs to be fixed. But they knew going into it that James Webb was going to be more of an engineering undertaking than they'd ever thought of. And that's because James Webb is a monster and has a bunch of new technologies. The sun shield, the way that it opens up when it gets into space, the size of its aperture, the wavelengths that it's looking at. It is a brand new telescope that's going to do brand new things. And it is so much bigger and so much more complicated than anything that's ever been launched before. And it's going to take as long as it takes. It's 10 billion. I'm sure by the time it's done, it'll be 12 billion. 2020, that would be great. Maybe it's 2022. It just takes as long as it takes, and I can be patient for it to show up. As long as it doesn't get canceled, right? Or as long as it doesn't really cause a lot of damage to a lot of other missions. That would suck. So for now, I'm patient, I can't wait, and it's totally worth it. Richard, if the Mars Curiosity detected and validated signs of life on Mars, how many probes do you think would be sent its way? Well, so many probes, right? But I think part of it is like, we've been through this before. When you think about all of the times that they thought that life had been found on Mars, Percival Lowell back in the 100 years ago thought he saw canals on Mars. There was the Viking landers that had this experiment on it that thought it detected the gases being put out by bacteria. There was the meteorite here on Earth that had, that was thought to be life on Mars. So at this point, you need to have overwhelming evidence. So if the Curiosity rover spots some Martian creature running around, then that would be an impressive piece of evidence, and you could expect all kinds of additional missions to be sent its way. But right now, the mission planners are being very careful, and they're moving they're taking step after step after step, and they want to make sure that they're building up the case for life on Mars very, very carefully. And I can't imagine any discovery that's going to change that timeline, right? We may find out that there is a hint of methane in the atmosphere, and they may be able to determine that it is due to some kind of life. That'd be really exciting. But where is it? How do you find it? More missions are going to be needed. So I think that we're going to see the regular schedule, unless Curiosity sees something alive right now on the surface of Mars and like scuttling around, or turns over a rock and there's a fossil of a fish on it. I think that would change everything. But for now, I don't think we're going to see any dramatic discoveries of life on Mars. All right, that's it. Question show time over. As always, if you want to get in on the question show, whenever an idea question pops in your brain, just type it in. I will gather them all up and I'll answer them here. I'll see you next week.